Hi, as per request, I'm just uploading the solution for the question number 18, January 2022, paper 4. This question, first part of this question, Faraday's law can be written as the induced EMF is equal to minus d by dt of n phi. State the name of term n phi and its unit. So n phi, what is n phi? The n phi is the flux linkage. N phi is, according to the definition, the answer is the what is n phi? N phi is flux linkage. And what is the unit for this? The unit is Weber. The unit is Weber. So it carries 1 mark each, flux linkage and Weber 1 each. Okay, it's not a big deal. It's a simple question. But come to the second question. A coil of 500 turns and radius 3 mm is placed between two poles of an electromagnet as shown. The terminals are connected to AC power supply. The magnetic flux density B, perpendicular to the plane of the coil, varies with the time as shown in the figure. Okay, so what is the reason for variation of this magnetic flux B perpendicular to the plane of the coil? What is the reason for that? Because the coil is rotating. It may be the reason. Forget about that. We don't want that part. But here, what is given? The magnetic flux versus time graph is given. It is slightly confusing because this question is actually not present in our textbook. So that is the reason why most of the students are finding some difficulty how to deal with this kind of questions. So what is our question? Because it's a 6 mark question, right? So what is that? Determine the maximum EMF across the coil. So the key word is the maximum EMF. Okay, anyway, for the time being, according to the Lenz's law, what is EMF? EMF is equal to the negative EMF. EMF is equal to not negative. EMF induced is equal to negative of the rate of change of flux linkage. That is minus d by dt of n phi. Any doubt? And by the basic definition, what is the flux linkage n phi? N phi is equal to total number of turns into phi is NBA. NBA, and generally this cos theta, NBA cos theta. Theta here is what the it's actually what is theta? Theta is the angle between the aerial vector for the area as well as the magnetic field. And here it is given in our question that it is perpendicular. Therefore, definitely the maximum EMF is generally what obtained by equation. What is that? N into B into A. So we will substitute this value of NBA here. So what happens? EMF is equal to minus d by dt of NBA. And here we can see the number of turns is constant. Even area is constant. But for sure, magnetic field is not constant. Why? Because that is the reason why the magnetic field versus time graph is a sinusoidal graph. So it's a varying magnetic field or magnetic flux density. So we will take out the constant. What is the EMF? EMF is equal to minus N into B, not B, sorry, my bad. N into A into d by dt of B. To get the maximum EMF, what we should, from this expression, to get maximum EMF, the anyway number of turns is constant, area is constant. Then to get maximum EMF minus d by dt of B, this should be what? To get minimum, this should be what? This should be minimum gradient. That's very important. It's minimum gradient, because then only minus into minus becomes positive and we will get a maximum EMF. So the dB by dt should be negative maximum. The negative maximum means from the graph we should find the negative maximum gradient. Then only negative and negative become positive, right? So see the graph. See the graph. So which all points this is giving the maximum negative gradient. That is happening at, always you should remember, that is going to happen at which point? At the 90-degree point. This is 0, this is 90, this is 180, 0, 90, the 90, not 90-degree point, the point at which it crosses what? The point at which it crosses the x-axis. It's not 90-degree point, forget about that. It's the point at which it crosses the time axis. That is the point at which it gives maximum negative gradient. Okay, it's very important. Okay, then what we should do? We have to draw a line. You know, basic idea how to find the gradient, approximate gradient from a graph. Okay, if it is not a straight line, the point from point to point the gradient will change. So I want to find the gradient at the point negative 0, gradient at the point 0.01. So draw a line. So I'm drawing a line here, and I'm just taking 2 points here. What are the 2 points I'm taking? This is 1 point I'm taking. This is the 1 point I'm taking. Okay, then another point I'm taking is this. So I would like to find the gradient of this straight line that I have drawn through 0.01. Even you can draw a gradient. See the point at which it shows this is the another point at which it should give the maximum negative gradient, because this is maximum positive gradient. Okay, so here we need to draw a line, and we can consider 2 points. What is this point? 0.01, 0, and this point is what? 0.011, comma negative 0.1. So then you apply the gradient. What is the negative gradient? We will get dB by dt is equal to y2 minus y1, or 0 minus 0.1 divided by 0.01 minus 0. This is 0.011, and that will give us negative 100. So that value d, that is our dB by dt, negative 100. So substitute this. So what happens? That we will get it as number of turns is 500, and it is a circular coil. Therefore, the area is pi into r square. So pi into 3 into 10 raised to minus 3, because mm we need to convert to meter, into the negative gradient, negative dB by dt. So that is equal to 500 into pi into 3 into 10 raised to minus 3 whole square. Then you substitute this value, minus into minus 100. So that will help us to find the answer, that EMF is equal to 1.4 volt. So the EMF is equal to 1.4. That is the maximum EMF. Maximum EMF is obtained at a minimum negative gradient of magnetic field versus time graph. That is very important concept. Hope you got it. And if you have any clarifications you require, you just drop a comment. I will explain you the concept in more detail. Thank you very much.